Today we're going to get much more involved in deductive reasoning, and you're going to learn some laws and how to become a good reasoner. Let me tell you, once you become really good at reasoning, and deductive reasoning in particular, you'll never lose an argument if you always apply the principles. So write your essential question. I'm not going to do it with you today. You go ahead and do that, or you can do it at the end. And here we go. What is deductive reasoning? Well, it's the process of reasoning logically from given facts, or sometimes you might see it written as premises, to a conclusion. So remember, inductive reasoning, you base your conjecture on patterns or observations. Deductive reasoning, we're dealing with facts. Facts never let us down. If the hypothesis of a true conditional is true, then the conclusion is true. So in other words, I've got if P, then Q, right? So if I know that P is true, if the hypothesis is true, then all this is saying here that Q is true also. This is called the law of detachment. Why is it called the law of detachment? I don't really know. Feel free to Google it and find out. So you got a conditional statement, if P then Q. If P is true, then Q is true. That's just the law of detachment. We'll use that in some examples here in a bit. All right, how about the next one? Right here. So I've got two conditional statements, if P then Q, and if Q then R. If both of these are true, then I can say if P then R is true. This is known as the law of syllogism. And here's an example right away to help this make sense to us. If it is July, so there's our P, then you are on summer vacation. So there's our Q. If you were on summer vacation, so there's our Q, then you work at Robex. There's our R. So the conclusion based on the law of syllogism is if it is July, then you work at Robex. So if P then Q, if Q then R, if both of those conditional statements are true, then I conclude if P then R. A couple more examples. If Joey gets an A on the final exam, then Joey will pass the class. So here's our P, Joey gets an A. Here's our Q, Joey will pass. Joey got an A on the final exam. So what is that telling me? It's telling me P is true. What can I conclude? Therefore, remember my three little dots, therefore, I can conclude that Joey passed by the law of detachment. All right, how about B? If a figure is a square, then its sides are congruent. So there's our P. Figure is a square. Q. Sides are congruent. Figure ABCD has congruent sides. There's our Q. What can you conclude? That doesn't follow the rule, does it? Because remember, our rule says I got a conditional statement, if P then Q, and if I know that P is true, but this is telling me that Q is true. So what can I conclude? I can't conclude anything because that does not follow the law of detachment. Cannot make a logical conclusion. Got to be careful. Okay, why don't you try C, see what happens. All right. Our statement here says if two lines are perpendicular, that's our P, then they create a right angle. There's our Q. If an angle is a right angle, there's our Q. Then its measure is 90 degrees. There's our R. So we have a classic case here of if P then Q, if Q then R. That is the law of syllogism. And so therefore we can conclude that if P then R, which would say if two lines are perpendicular, then the angle formed measures 90 degrees. That is the law of syllogism. Okay, be sure to remember this. In order to use the laws, the conditional statement or statements must be true. So here's an example where we're using both laws together. Using the laws of its detachment and syllogism. Here we go. If a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. So let's take this part right here. And using the law of syllogism, what can we say? We can say, by the law of syllogism, that if a river is more than 4,000 miles long, then it is the longest river in the world. Law of syllogism. If P then Q, if Q then R, then if P then R, then it is the longest in the world. Okay, so that's just using our first two statements. Now we've got another statement that says the Nile is 4,132 meters long. So if we look at the statement that we made right here, if a river is more than 4,000 miles long, then it is the longest river in the world. So here's our P, here's our Q. And so what are we saying by saying the Nile is 4,132 miles long? We're saying P is true. Therefore, what can we conclude? That the Nile is the longest river in the world. And that's using the law of detachment. So we use the law of syllogism first, the law of detachment to get our final conclusion. The Nile is the longest river in the world. Okay. Put a question mark there if you need to ask about this in class. Okay, now here's something we'll be doing a lot of. Look at an argument and decide if it's a valid argument. And when we say is it valid, we mean does it follow the rules of logic? If Roger gets a part-time job, then he will buy a new bicycle. Roger buys a new bicycle. Well, I'm going to label my P's and Q's like I like to do. So here's our P. Roger gets a part-time job. Then Q is he will buy a new bicycle. Roger buys a new bicycle. So there's Q. So this is not valid because it does not follow. It looks like the law of detachment, but it's not. So we're just going to say it does not follow laws. It breaks the law. How about this one? If two angles are vertical angles, then they are congruent. So there's our P. Two angles are vertical angles. They are congruent is Q. Angles 1 and 2 are vertical angles. So that's telling me right here that P is true. Therefore, I can conclude that Q is true. Angles 1 and 2. So yes, this is a valid argument because it follows the law of detachment. It's a logically sound argument. If Sarah misses school today, then she will miss tonight's game. All right, this looks like it's going to be a law of syllogism, so let's see if it works out. If Sarah misses school today, that's P, then she will miss tonight's game. There's Q. If Sarah misses tonight's game, there's Q. Then she will be benched for a week. There's R. So let's write over here what we should be able to conclude would be if P then R, right? If we're using the law of syllogism. But what do we have here? Sarah was benched for a week. Sarah, that's R. So they're telling me R is true. So did Sarah miss school today? No, I cannot conclude that. I cannot conclude that because it is not the law of syllogism. So you got to be very careful about the order thing. I think it will really help you if you label your P's, Q's, and R's, and then you can see quickly, because what this conclusion here is saying is they're telling me the conclusion is if Q, then R, right? And that's not what the law of syllogism says. So we cannot make that conclusion. It's not, I mean, you can, but it's not valid. It's not a valid argument. about the law of syllogism, it should remind you of the transitive property. Transitive property from algebra, right? Because the transitive property says if A equals B and B equals C, then A equals C, right? So law of syllogism, maybe that'll help you to remember it. Okay, let's do this example here. 3 conditional statements. I want you to pause here and I want you to try to do this yourself. This might take a few minutes. Come back and I'll go over it with you. Okay, so first I took statements A and C, because if a cat is the largest of all cats, then it can weigh 650 pounds. If a cat weighs 650 pounds, then it is a tiger. So using the law of syllogism, then I can say if a cat is the largest of all cats, then it is a tiger. If P then Q, if Q then R, then your conclusion is if P then R. So look over these other 2 that I did, check them with yours. If not, if they do not match, then make sure I'm not wrong. And if I'm not wrong and you don't understand where you went wrong, then let's talk about it in class. And are there any more? These are just the first 3 that I spotted, but are there more conclusions that you can make using the law of syllogism and these 5 statements? I don't know. You tell me. Okay, now, we haven't talked about Venn diagrams yet. I do know that you've learned about Venn diagrams, so here's just a little chart. We'll talk about this in class. The law of detachment, this just shows you right here that, okay, if P, so your your hypothesis will always be inside of your conclusion, all right? If P is true, then Q is true. All right, so if it is sunny outside, then I will go to the pool. So anytime it's sunny, I'm going to go to the pool. So there we go. P is always inside of Q. Indirect reasoning, if P is true, then Q is true. If not Q is true, then P is not true. So that's just saying if in this case I would be out here, I would not be inside. And don't worry too much about this. We'll go over this some more in class in our examples. The law of syllogism, which you might hear someone refer to as the chain rule. I'll always call it the law of syllogism. Here it is. If P is true, then R is true. So of course you're going to have P, the hypothesis, inside of Q because that's the way it always works. And then R is our overall conclusion, so both P and Q would be inside of R. All right, and then U would be inside here of P. All right, and the OR rule, P is true or Q is true. If P is not true, then Q has to be true. Okay, so you know OR, this is the symbol for OR, right? And you remember with your Venn diagrams, if you have an OR, then there's no overlap. So that's why we would have 2 separate circles, not overlapping. And P is not true. Q is true, so that's why I would have my star inside of Q. We'll do much more on Venn diagrams next lesson. Okay, so what you need to remember is if P is true, then Q is true. Remember, here is our law of detachment. It says if P, then Q. P is true, therefore Q is true. But if I say it backwards like this, if I say Q is true instead of P is true, then this is known as a converse error. Okay? So if you say Q is true, therefore P is true, you've actually said it backwards, right? You've used the law of detachment backwards. That's known as a converse error. The inverse error, so we say if P is true, then Q is true. P is not true, therefore Q is not true. That is not a valid argument because it does not follow the law of the detachment, and that's known as an inverse error. So what I want us to do, what I would like you to do And we'll look at these first thing tomorrow, so don't let me forget. Over here in this space, I want you to make up an example for each one of these cases. All right? I want you to write a conditional statement, and then I want you to make a converse error with it. And in the next one, I want you to make an inverse, or you can just have one conditional statement, then do a converse error, then do an inverse error, and let's talk about those in class. Let's see what you come up with. Write your summary, and our next lesson will be on Venn diagrams.